Okay, welcome to this video, and in today's video we are still looking at traits in Rust, and today we want to extend our understanding of traits and we look at generics. And before we look at generics with traits, let us first look at the traits, the generics themselves. And we need to understand, for those of you coming from C++, you know what generics, one of the ways we achieve generic programming in C++ is using templates, and kind of similar like that way in Rust. So let's look at generics first. So we have a function. In Rust, we can define anything as a generic implementation of either a struct or an enum or a function or even the implementation block itself. Let's dive in and see. So we have a function, simple function here, give me, and this function takes an argument value, but we want to make this value a template, a generic value, not template. C++ here. So it's a generic type or argument, and we expect to do something within the method. We won't do much, but we are declaring a value that so far we'll just lay there. Okay, so we have the function there. We can see what we can get if we go to the main function. Okay, and for what we want to test out, let us just declare random variables. So we let a equal to maybe a string generics, and we let, this is not let. Okay, we let b equal to maybe this value 1020. Yeah, lovely byte there. So we want to see what does give me if we pass a, what happens. And then we use give me to pass b. We need to see that we are technically not expecting something to be printed out, and that's why we want to use this package, utility package called the name command, and the name or nm is a utility package from the GNU bin utilities package for viewing symbols from a compiled object file. So okay, this is how we run nm package. Nm, we are calling this main, and then we are creating a pipe, and then we are using grep. These are some of Unix commands, and then we're calling anything that has give within our binaries, and we are going to run the file using the normal compiler from rustc main.rs. okay, and then to see what is happening, we are calling the utility package nm, and this is nm main, where yes, main, and we are using a pipe to grab this grep and anything that has give within it. Okay, and voila, this is what I wanted to show you. So we are seeing that we have at least two binaries created within the main.rs, and that shows that this function, at least it can handle anything. It's literally a binary file, a generic function. But we are not done yet. We've said that Rust can allow us to declare many things as generics, and these could be structs, could be enums, functions, traits, methods, and others, even the implementation block. So we can play around with that and see if we have a struct. Let's call it a generic struct, yes, and a type. It takes, which is generic, but we can also pass those from the angle brackets to mean that the return type we are expecting will be also generic. We actually don't have to implement it. So we can also have a struct, maybe container, and this struct is expecting a return type. Now this one we can put some variants that we expect, and still these will be generic. So you see how powerful generic programming can be. We can also declare an enum or generic enums, and this could be enum. Maybe we want to transmit a signal, transmission, and of course we expect everything to be generic, such that we are not tying it to a type. So even the signal is a type. It could be a string, it could be anything. No signal, okay, even that. We can also write an implementation block for one of the generic types too. So though it might get a little bit verbose, but let's implement the implementation block for the struct container. And this could be implementation container. Our container is generic, and we want to we talked about the new function, which is literally like the constructor. So it instantiates the container with its parameter, and returns self. We've talked about self as the type areas, and container returns usually basically it contains the item itself. So the self keyword, we've talked about it in Rust as a type areas for the type on which the method is being implemented. So in this case, the self refers to the container itself, which is the generic type, and it provides a shorthand for referring to the type being implemented. Those are things we need to know. So if we come to the main function, we can test out some things and see what comes out. This could be, we can define a variable, maybe container, or equaling to container, the one we've defined, and we want to access the constructor by using the double colons, and this could be maybe 44, and we might need to print out something on the screen maybe, and we are saying that the container holds container dot item. We are going to get rid of this, of course. There should be a comma. So we want to first test out this, and this could be Rust C and error main.rs, and we are getting yes, and I wanted to show this cannot find type T. So that means we have to declare the implementation block also to be of a generic type. Okay, so to do that, once again, okay, voila, everything seems fine. And if we run the binary generated main, we see that we are seeing the container holding 44. You can go ahead and test out with maybe a string and anything else. So that's all I wanted to talk about today in generics. Now, switching gears to what the main video is all about. The main video is about traits with generics, and we might have to get rid of this. Now, we're talking about traits with generics, and now that we have a decent idea about generics and traits, we can explore ways in which we can combine them to express more about our interfaces and at compile time. So we'll look at it. Actually, I need to comment out everything here. Okay, let's imagine a game, and we are declaring these unit structs, game struct hero. We might have a hero in the game, and the struct maybe the enemy. Makes sense. So now we want to implement a generic function. We want to implement one of the structs, at least the game, and we want to implement game, okay, as the struct. And because it is we want to implement a generic method or function, we will sorry about that, this is load. We want to load our game initially. That's because when you start a game, you want it to load to the device, and because it is load, it is generic, that means we want to load any game type, and we want to pass out some things. So first of all, we need to create an instance of the game, of which that requires us to pass self and the entity itself, okay, and which entity will take on any type. And the entity we are referring to in this case is the game entity itself. So we want to instantiate that and initiate it, and saying that the entity initialize it. So we assume that there is an defined, or there is a function called init method that initializes the entity. There's a problem there. Okay, fixed. Okay, so we have defined the load function, and yeah, let's test it and see. So we create the main function, and in the main function we are creating a game instance, okay, and we are saying game.load. We want to load the enemy maybe, and then we are saying game.load even the hero. So the game should start with these two entities, the enemy and the hero. So what do we expect here? Okay, I expect problems here, but let's run and see. Rust main.rs, yeah, and this makes sense. We are saying that expected closing brackets of that entity. Okay, this was a comma, I got that, but that's not the reason why. My concern is about this method not found in T, the init not found for this type parameter. So meaning that the method is not found for a method, and that means the load function or method in our code cannot know or cannot assume by default the init method exists on T. And by the way, if it knew that the init method exists, that means it kills their idea of generics. Like, it wouldn't be generic at all if it knew, and would only be able to accept types that have the init method on them. I don't know if that makes sense. So there's no way it could know about this. So now there is a way that we can let the compiler know of this and constrain the set of types that load can accept using traits. So this is where the concept of trait bounds come into the picture, and we can define a trait that can handle this. Let's define a trait called loadable that will help us clear this mess. Okay, so we declare a trait and we call it loadable, and we create a function in there called init. So it's a trait, and remember the concept of traits is shared behavior. So that means anyone can share this, whoever needs it. Okay, we don't implement that init method fully. We can implement, that means we need to implement the loadable trait for all the entities we are talking about, the enemy and the hero. Yeah, let's do that. So implement loadable for enemy. Okay, and function init. Remember that's off, and all we want to do is printing something on the screen, and we want to show that the enemy is loaded. Okay, so that's done. So we can do the same thing for the hero. Implement loadable for hero, and the function init, we do the same signature solve, and we're saying print lan, and we are saying hero is loaded. Okay, so we are implementing, first of all, we've implemented the trait that is going to handle the loading of the enemy and the hero. So but we need to make some changes to our game, and if you don't believe me, let's run and see. Okay, yes, the method not found. Still we are seeing something like help. Items from the traits can only be used if the type parameter is bounded by the trait, and this is the concept of bounding traits. So that means a function load within our game entity must take a parameter type but being handled by the loadable trait. So that means we will extend this here and we say loadable, and yeah, I think that's all we need to do for now. Let's see. Let's test once again. Voila. And when we run main, enemy is loaded and hero is loaded. So that's all about generics and traits, and we've talked about this concept of traits with bounds, or this concept of trait bounds, whereby traits are bounded to this function or these methods in a way that they can be combined to bring out something. So that's all I had for you guys in this video. Please don't forget to leave a like, comment, and subscribe to the channel. Bye bye.